Hello, welcome to conservation of momentum scenario number 3. Now, this scenario, pay attention to the change in direction. There are two objects, cars, human beings, moving in opposite direction. M1 is going this way, M2 is coming this way, so we can talk about head-on collision about to happen here. Take note that they have the same mass. M1 is still 10 kg, M2 is still 10 kg, but M1 was moving at 10 meters per second and M2 was moving at 5 meters per second in an opposite direction. So to make this thing very clear, you could actually put your negative sign there to show that you recognize this direction of M2. So when you are going to write down the conservation of the momentum before collision, so we're going to end up with something like this. So we're going to say the momentum before would then be equal to M1 U1, okay, plus M2 times minus U2. Or you can leave that out until you are ready to put the figures in, okay? M2 U2, the same equation as before, because this total, we're adding everything together. But because that velocity is a vector, momentum is a vector, we should recognize when the direction is different by the use of minus sign. So we now say this is 10 kg multiplied by 10, that's going to be 10 times 10. 10 kg multiplied by minus 5, that's going to be 10 times minus 5, and that leaves us with 100 minus 50, which is equal to 50 kg meters per second. So, and that will be the total momentum before. Call that equation number 1. The second equation will be derived from total momentum after collision. And we can say, again, very common scenario, after head-on collision, they stop, they start moving in the same direction. So we say M1 plus M2 times V. Remember, we do not know what the sign of V is going to be, but our calculation, if it's done correctly, is going to bring that out. So we then say M1 is 10 plus 10 times V, and that leaves us with 20V, as you've seen in previous examples. And the next thing to now do is to equate equation 1 to equation 2 because of the conservation of momentum law. So if momentum is conserved, then equation 1 must be equal to equation 2, which basically means momentum before must be equal to momentum after. And momentum before is 150 kilogram meters per second, 50 kilogram meters per second, and that is the same as 20 multiplied by V. So if you divide both sides by 20, you're going to end up with V, okay? So this is 20 kilogram times V. So you're going to end up with V equals 50 over 20, which is the same as 2.5 meters per second. Note that it is positive, which means this V is actually moving in this direction. Okay? And that is how a question like this is solved. I hope that makes it very clear. See you for another example